Chance this before now.
Jim the Spring.
And now it's just like, oh, I have my... All right. Will, do you have your shaft set up yet, or you just have designed your shaft yet?
No. We don't have it finished yet.
All right.
Fired. It's funny, the weeks after spring break are much more filled than the week of spring break.
Amazing how that happens. All right, so what do we want to make?
Another chess piece.
Another chess piece.
Or a J.
A J?
An ice cream
really
cone.
hard, but
A J is rotationally cement.
Let's do one.
It's like a bowl.
Let's build a house.
yeah, let's do a house.
One cool thing that a friend of mine did at Georgia Tech is he took an audio file, and used a very sharp tool, and cut the waveform into the surface. And if you'd run a piece of plastic over it, it would play the audio file.
That's well, I mean, that's what cool. What was it?
So cool, like music notes.
The record player? No, before the record player, the Edison's thing, there was the wax cylinder.
But that was still a groove in and out. This was just the surface profile.
Oh, okay.
Could you get the artist's voice out of it and everything?
It had to be very short.
Yeah.
Clip. I didn't know how I did it.
So you can like go all the way around the room, you're like sprinting around the room. I'm listening to my favorite song.
So one thing they were thinking of marketing it so you can then use that to cast plastic or whatever, and then you can just strip on frosted flakes and hear Tony say they're great. Anyway, that was neither here nor there, and it's not today, and we don't have a sharp tool like that. So, all right. So one thing we want to look at over here.
Oh, careful! Don't die, Rochelle. You almost died. I'm fine. I'm gonna tell the camera so that they know Rochelle almost died.
So, over here we're using Mastercam 2. Over there we're using Mastercam 3. Now we're using Mastercam 2.
Mastercam 2.
The reason we're using Mastercam 2 is that's what has this machine loaded into it, and I haven't had enough time to figure out how to load this machine into Mastercam 3. So for Mastercam 2 to work, that machine over there is the license server. So this machine says, hey, did they buy a license? And if that machine is off, it won't say anything. So that machine needs to be on. You don't have to be logged in, but it has to be on for this machine to run Mastercam. So looking at it, basically what we have is X is in this direction and Y is in that direction. So when we're drawing our part over there, we want to make sure that we're drawing our sketch in the XY plane. Otherwise we have to rotate it around and just get confused.
Isn't it going to be rotated around anyways?
In other words, rotate our drawing. If our drawing is like this, we have to rotate it so that our drawing is actually in the XY plane.
Along the x-axis.
So the rotation should be around the x-axis for everything to work out nicely. All right, so we're going to do a sketch. So sketch, actually we probably want a revolved thing. Sketch it in, the XY plane is the front plane. And then you basically want, you set 0, 0 at the far end of the workpiece and work your way this way. So you want to draw it to the left of 0, 0. Are we going to try a chess piece?
Sure.
Living dangerously.
I don't think that's rotationally symmetric. Oh, no.
All right, so there is the head. And then what do we have? What else do we have?
Face.
The face.
What is the horse called?
We're doing a horse?
Yeah.
That's probably a little too hard for... No, I didn't want there. This is your solid... So you don't have to do this in SolidWorks, but go there, and what is it, straight, or it goes out a little bit? The pawn.
Oh.
And then... What else do we want? All right, that looks looks sort of pawnish.
That looks really funky.
It's really funky. So we got to get rid of the things that are outside because it needs a continuous path.
Oh.
Oh, I see.
I thought it was bicep.
There we go.
It
Bicep.
kind of looks like an ornament.
It's bicep.
All right. So, and then we want to revolve it around that line right there.
Hey.
Whoa.
Looks like a sorry piece.
It does look like
It's better than that. It's not sorry.
There's a bump.
All right. But
There's a ring right under the bump.
It doesn't have to be perfect.
we don't have that sharp of a tool.
Oh.
That's what you can do if you injection mold your bond.
Brandon's an overachiever.
All right. So, it would probably nice to add a fillet. Wait. It looks like a pond, but isn't the right size.
Oh no.
Let's add some.
Make it about 3 feet tall.
About 3 feet tall.
2 inches is sufficient.
I think we should make it oversized.
I'm thinking it should be like 7 feet tall, so maybe we can climb on it.
This is what
It's
I
actually not too
That
bad.
we make it fit inside the
How
How big is it?
This is 0.3. So what we have is it's 3/4 of an inch thing of wood. So half of 3/4 is
1.5 quarters.
Yeah.
so 3/8 is
engineers do math.
3 divided by
0.375?
is 375. But if it's not quite in the center, then you're going to get a wobbly part. So you want to make it. You want to actually cut something. So if we make this 0.36, then we're sure we're going to actually do a cut. And then we can make this, let's say 0.17. Does that make me big-headed? And what else do we need?
I knew it was on
Did you use that 0.17? You're using diameter, right?
That's the radius of 0.17.
Oh, 0.17. Okay.
Yeah.
Okay.
And should we make it 1 inch tall, let's say?
92.
All right, so it actually, I guessed right on the size.
Good want to make it 2 inches.
This is looking a little flat down there.
Do a little fillet.
So we should probably fillet it. Let's see. Right, how about there, and there, and there?
Whatever the smallest tool is.
That's like one.
Whoa.
That looks like a sorry piece.
Now it's a
Now it's a sorry piece. It's okay, we can play chess with sorry pieces.
All right,
Different colors.
different colors. All right, so now we have a nice piece. Let's say we should call this
Nice piece. Sorry.
pawn, or sorry.
Sorry, pawn. Sorry pawn.
Okay, so now we have a sorry piece. Now, what do we need? What does that need to know?
Where?
Does it need a 3D shape?
No. It needs
No.
paths.
It just needs the path. It just needs the outside surface of the thing. It doesn't need the entire 3D shape. And so the easiest way I've found to do that is to actually export this. Let's see, let's look at it. We want the front view. And then we want to save as, if we save it as a drawing, an AutoCAD drawing, AutoCAD DWG file, then that can also import a DWG file. And it's AutoCAD, so it's dear to our heart, we can edit it. The problem is that we have AutoCAD 2012.
Oh no.
We're using Mastercam 2, so that can't read AutoCAD 12 files. So you have to save it as a previous version of AutoCAD if you want to open it up there, if you edit it in AutoCAD. This will save it in the proper version of AutoCAD. But if you edit it in AutoCAD, then it won't import it. Fortunately, AutoCAD isn't evil, and it actually allows you to save it as a previous version, unlike SolidWorks, which forces you to buy the new version of SolidWorks. Poor Andre.
Oh.
You bought the wrong version?
Yeah.
He bought the right version. Classic. Oh yeah.
Well,
He bought the right
Does
version.
this read AutoCAD 2012?
No, it doesn't.
It won't
Because
at
it
all.
was written, it's actually 2011, I think, is when they, or 2010 is when they changed it, and that's an older version.
It reads at 2010?
It doesn't, it's 2007.
Oh.
Why don't they just have the same file type for like 10 years and then change it every 10 years?
Because if you add new features, like the new version of AutoCAD is sort of like SolidWorks, that you can do a parametric drawing, that is, you can dimension it and then change the dimensions and it gets bigger. So that's a new feature in AutoCAD. Well, since it didn't exist before, then you can't, there's no place to save it.
You still make the file types compatible, though.
Not backwards compatible, because there's no way you can, there's no place, this doesn't, the
True.
2007 doesn't know about a parametric drawing, so how can you make it compatible? So it's backwards compatible. That you can read older, the new AutoCAD can read old AutoCAD drawings, but not forwards compatible. Anyway, so here is our very fine chess piece. We're looking at the current view. You can save different views, but what we want to save is our current view, which is our front view. And then this is basically what we have. And then all right, so we have now successfully saved our AutoCAD drawing. And so we can come over here through the power of the network. We should be able to open it up over here. So File, Open. This would be ZBR442. And we want it to be AutoCAD files, so sorry. All right, so we've successfully added our chess piece into our drawing. So this is our basis of what we're going to work on. Now, all these beautiful lines right here, what are these from?
Changing tools.
Now, the lines are because it's rotationally symmetric, so you'll see lines across the front. Those are not things we want to cut, so we need to get rid of them. So we can get rid of them here, 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 here. But looking at this one, we need a little bit of the line. So we can't just get rid of the line, we have to trim it. And so this does have editing. So here's your trim. And then we want to trim, divide it, get rid of the middle part, right there. So now we basically, otherwise it gets confused because when it comes to a T, it just gets lost. I don't know where to go from here. So you needed to make it easy. So this might be easier to do for you in AutoCAD if you have a more complicated shape. So now we have a beautiful workpiece. Now we need to tell the machine, not the machine, the software, what type of machine we have. We have a lathe, and then there's a default lathe or a Techno Lathe MD. So you need the Techno Lathe MD, otherwise this doesn't understand what you're saying. So, you want to pause it?
Me?
Yeah. Right, so what we did is we deleted the interior lines. Now we need to set this up. We did a machine type, lathe, and then Techno Lathe. It's the only option, so you can't really make a mistake. Now, basically what we want to do is set up where our stock, that is what we're going to be cutting. So we click on stock setup, and then it's the stock, which is the part you're cutting. There's the chuck jaws, which are what's going to hold the workpiece, and so it's checking to make sure that you don't run into things. So the stock setup properties, outer diameter is 0.75, and then your length is basically how much of it is going to be sticking out of the machine. And so I'll just say 4. 4 is plenty.
You just want it to be more than the piece height, right?
More than the piece height, but this is how much. It's not how much is sticking on the machine, but it's how much you have total. So it includes how much you're going to grab on it. And so our chuck jaws were basically it's outer diameter 1. This is the configuration of our jaws, where we have this what's right here. So this is the configuration we have. And then the position is from stock, which says, basically gives you the diameter of your chuck. And your grip length is how much we're going to be holding on, and we'll say it's going to be 1 inch. So that means we're going to basically, we said the whole thing is 4 inches long. Whole thing is 4 inches long, and we're going to grab it with an inch, giving us 3 inches sticking out. Hit OK. And tailstock is if you can hold it at both ends, and so you can set it up to hold at both ends. We're not doing that today. But if you have a longer shaft, then you have to actually hold it from both ends. So now if we zoom out, you can see here is our stock, and here is the lathe chuck that's holding on to our stock. See, this is basically what we're going to start with. So, I guess this is a little simpler. So, tool paths that we have. We have a lathe rough, a lathe finish. And so, a roughing cut is usually a deeper cut. A finish cut is you're going and just taking a little bit off to give you a nice smooth surface. So, roughing cut, you're going to deeper cut, quicker feed rate. Finish is usually just a single path. So if you zoom in on the icon, you could take off your material in several different passes with a rough, where the finish is assuming all the material has been removed already. There's threading, so you can cut threads with a thread cooler. A groove, if you have something going in and then out again, that's going to be a groove. And then facing would be if you want to make the end of the thing flat. So when we did a rook for the other class, we used facing. This one we have a round end, so therefore we can't face it. And then cut off is basically cutting it off like that. You can also use a drill. It's weird on your mind to see a drill, and the drill is stationary and the part is rotating. It just seems wrong. But that's one way you can cut holes in the middle of the part. You can mount a drill over here. But we don't have, we basically have to turn the crank by hand, so it's not a CNC operation, where the other paths are that. So, those are basically what we have. So let's do lathe rough. So I'm trying to figure out how this is going to work. Lathe rough, we'll start with the lathe rough. And basically, you basically set the path you want to do. So let's go from here. It's confused. All right, I've never done something with a round end. All right, so it basically wants to do this entire surface, which is not what we want. So we can draw a, say, draw a line like this. And then we can go back to our trim and get rid of the part we don't want. All right, so now we can try again. Tool pass, lathe rough. From here all the way out to there. So we basically have one tool path. And then this is basically, these are the standard tools. What I've done is, for a couple of our tools, it's in our tools. And so this is the easiest way to find the tools that we actually have, rather than all the tools we could possibly buy. If you buy a different tool, then you can add it to that. So basically, we have two basic tools. Now, we basically want to use the left one. The left one is, where is it? This is the left one. So it's cutting on the left-hand side. Sorry, I forgot. So it's cutting on the left-hand side. So this is how you would face the operation. Now, this is weird, and then it shows you the picture like you're underneath it looking up. That's, I don't know why.
You couldn't put the tool on the bottom side on that drawing?
This is the standard drawing that comes with the program.
Oh, okay.
So, it's confusing.
Yeah.
So now you can preview the operation just like before. I would probably want to preview the operation and slow it down just to make it look exciting. And so it's going to come in, come in, come in. So that's basically what we have. And so you can see that we are, lying down under the machine looking up. That's how it is. It's not that intuitive, but that's what we've got. So we basically have this surface here. Now we can come through and do a finish on the same surface. And same tool. And now if we preview that one, okay, so zip, zip, zip. Ooh. What's missing?
The shape.
The groove part, yeah. You got to get a new groove. So basically we need to add a groove tool path. And it's not just a straight groove, it's actually a chain. And so we want to go for that. No, not that way.
If you click behind it, will it change the red arrow?
Let's try this again. Tool paths, groove tool path, chain. From here to there. See if it'll like it that one. And then the tool we want, let's try using the same tool. I think, let's see what it is. Error making tool. I guess we'll just use a cutoff. So we don't really have a good grooving tool. It was working the other day. Chain from here. We want to go. Well, let's go the other way. Why? Reverse direction. There we go. All right. Well, like that groove. Library tool. From that. Check that. No, it doesn't like it. Tool path. Groove. All right, what did that do for us? I don't like the groove, it's a little confusing. All right, so the groove, we're basically going to come in, slot it out, and then go around like that.
Interesting.
And then lastly, we want to do a cutoff tool bath, and that, and we'll use our collision with Scott. So, I don't know why it's having a collision with Scott. So we'll have to look at the code to make sure that it doesn't. Let's see what it looks like. All right, so it seems to be okay. It gave us a warning about collision with stock, so we need to confirm. I think I know what's going to cause that. So like before, we press G1 to generate the G codes.
Does that have a button? G?
G1 button.
Okay.
Creates the G codes. Sorry, that's the name of our file. So if we look down at the end, this is when we're going to collide with, it's warning us it's going to collide with the stock.
Isn't that what it's supposed to do, is hit the stock?
Not when it's moving quickly. So M6, G. So I believe this is, where is it colliding with the stock? I think that's, back out, go in. I think that's going to be okay. So I basically backed it out a little bit more. This X, positive X is away from the surface. So I think that should...
Did you tell it when it was going to contact the surface?
It didn't tell you. So from past time, it's when it's rapiding over to plunge is usually where it contacts the surface. So what I did is I backed it out a little bit as it's going to rapid over. So hopefully it won't.
Did you tell it to stop when it gets to the center?
Yeah,
or is that programmed?
It automatically programs it in for you. So let's
That'd be exciting if it did.
save it. And then the program we have is Techno. And if everything works right, it shouldn't work. Because it's off. Emergency stop is on.
Now, when you had to change bits because you were using the carbide one first, did you have to reorient it?
So the first thing we need to do when we're doing that is to orient where the bits are. So tell the machine where the bits are. So we try. So we can preview, let's see, what do we call it? Sorry. There's lots of shafts. Sorry. So basically, it says a new sorry.cfg has been created. So basically, you need to set up what the tools you're using is, how big your stock is, things like that when you're setting up, whenever you set up a new part. You can borrow it from another part. If you have another part which uses the same tools, you can just use the same configuration. That's the easy way to do it. But I'm going to show you how to do it the long way, just so that in case you need to do it. So that's what it's saying is be sure you check out the setup file. So looking at the setup, basic speeds, and then the X offset, that should be the radius of your part negative. So it's basically telling you, what you're doing is you're telling where is this edge of your part, where is 0, 0 on your command. And so that will be negative the radius of your part. And so half of 3/4 is 3/8, 0.375. SolidWorks, you can do 3 divided by 8. And then home after run, you usually want this no. If you say yes, then it clicks its Ruby slippers together and goes home, which is way over there, which adds another minute to your production run. So you don't want to go home. You just want to basically stop where you're at. So that's set up, and then your spindle of your tools. These are your tool lengths offset. So you basically set 0, 0 for tool 0. Tool 1 is this tool. So you basically align this corner of the tool at 0, 0. And then if you look at other tools, here's a different tool. It's going to have a different 0, 0, but it's basically what you do is you have tool offsets, which are the point this 0, 0 compared to this 0, 0. And so for each tool, you'll have a tool length offset for that particular tool. So that's what you need to configure it to set your tool length offsets. So
If you make it easy, you could have all of those offsets the same, couldn't you?
you could, but then you have to very precisely with the set screw stick these tools in the same place. And the problem is when you have one like this and one like this, you can't, this tip and this tip are on the opposite side of the tool, so you can't really set it up like that. But once you've calibrated it once, since everything is in there with a set screw, it's not going to change.
Yeah, unless you change the tool.
Yeah, if you change the tool in there, then you have to play with, you have to set a new tool length offset. But normally all you need to do is load the previous ones in there. So, that's what it thinks it's going to end up with when it's done. Is that the right part?
Pretty similar. No, there's a weird thing right in the middle.
There's some weird stuff going on in the middle, but it's basically assuming we have a sharp point like this, where what we have is a flat, we said we're going to groove it with a flat tool. So the shape of the tool is different, but you can at least see that this is the right part. This doesn't look like a rook, this looks like a pawn. This is what it thinks it's going to end up with. It may or may not actually be what you want to look up, what it might be. Okay, so whenever we start moving things, we should put on safety glasses.
Safety goggles.
And where's the safety goggles go?
Francis. We had them. Oh yeah, it was Francis.
I understand how you lenses. Yeah, they had the whole nerdy. Oh, I still have it. It's so many lines.
When I was at the Lathe, we had to use safety glasses for everything. I would forget that I was wearing safety glasses. So like I'd walk into like grab pizza and everything, and then everyone would like, just wear your safety glasses.
Oh, you got the good ones.
I just found them.
Oh yeah. You found the right ones.
I found the ones that aren't going to give me a free credit.
All right, so we'll all have raccoon eyes.
Oh, don't look at me.
All right, so basically what we have, this is the clamp to basically move the workpiece in and out. We said we'd have about 3 inches. That's more than 3 inches, so we're going to not hurt ourselves.
Will it start on the end or will it automatically start in the middle?
Well, we need to tell it where 0, 0 is. So it'll tell it, wherever you tell it 0, 0 is, that's where it's going to start.
So even though it's more than 3 inches, it won't start halfway in because that's
correct. Unless you tell it to start halfway. So this is basically what we have. You always want to make sure this comes out, otherwise you have projectile motion, which we could probably analyze from dynamics, but fortunately we have this screen here which will protect us. And the wonderful thing about here, as compared to there, is the emergency stop is actually outside the protective covering, where in there is inside the protective covering.
Isn't there that switch thing also so that like when you open up the...
So it actually has a lock, so you can't open it up when it's running.
Okay, so it's a lock.
So it's actually a lock, which you could probably overpower if necessary. But
I just thought it was. I thought that was an extra switch, so it was like if someone were to open that up.
You're good with them.
no, it actually latches, sort of like your washing machine. All right, so what do we need to do? We need to add our tool.
We're going to do this tool. We're going to add it.
Okay, so like before, we have jog speed and jog step. Now, if that's not coming out of there straight, Where's the most accurate place to measure the diameter? Right, we don't, if this is slightly becocked, we don't want to measure at this tip. We want to measure it as close to the chuck as possible. That's most accurate to find 0, 0. So we can, I think it's supposed to automatically stop, but I'm not going to push my luck. I think it has a limit switch inside, so you can't run it into the chuck.
Man, you took that speed down.
Yeah, I know. I don't want to. You can run into things you don't want to go very quickly. So then, like before, we can use our highly calibrated piece of paper. Unless, what is a better way to set the offset? What's the best way to set the offset? Like this? Or in it when it starts cutting?
No, that's fine.
Is it fine?
And you just drag it up and you're within about 1/1000th of a half.
Oh, I've been using a big piece of paper. So
That's going to be close enough because there's going to be a little variation in the.
okay, so Wes says that's close enough. He's the experienced one. So we want to 0. What direction are we zeroing?
X.
X. X is in and out. Z is left and right. So we want to 0x. So now X is set up. The programming thing is in the XY plane. The computer is in the XZ plane.
Okay.
You always have to speak, you have to interface with it in its proper language. So now we can back away. Or we're backing away very slowly. And then speed up. And this is where we basically are setting the 0, 0. We need to set 0 for your Z.
I was freaking out.
So you can move it around with the thing open. You can't cut with the thing open. All right, so basically, is that okay for Z, 0?
Show.
Close enough, we have at least 3 inches sticking out. So, how do we set that point to 0?
At 0.
0 button.
0, Z. Now we want to use this for reference for the future. So when we're calibrating the other tools, we need to set where this is where Z is equal to 0. So how can we make our workpiece obvious that this is Z is equal to 0?
Cut off the end.
Cut off the end, very good. So you can turn on the spindle.
This is 10. This is there.
And you want to make sure your jog speed isn't that fast. You don't want to like run through the part. You got to give it time to remove it, and then we can just go through. Back it out. Probably back it out a little faster because we're not cutting anything anymore. Patience, patience. Go out, patience.
Doctor makes
No patience. All right, that should be good. So now it won't let you open it when it's running.
That's really strong.
And this handle, I always grab, it doesn't work. All right, so you can tell that this tool is properly set up because at the end of here, there's no thing sticking out. If your tool is too low, then you end up with a little nub at the end that it doesn't cut off. So there's our our tool. We now have a reference. We zeroed, this is at X is equal to 0. Now we can set up our next tool. And our next tool is this tool right here. And so you can clearly see that 0 is not in the same place. All right, you want to clamp it down. So, how do we figure out where 0 is?
The 0 button.
Not the 0 button, we need
The
to.
tool in there.
So we basically need to set the tool length offset. This is going really slow. Hopefully we're going to set it up right. So again, we can use our paper trick. Where's our bigger piece of paper? Right here. Oh, there you go. Let's see, how close are we? Step. Couple thousandths more. Okay, so now basically now we don't want a 0.
Tool?
We want to go to tool. We're wanting to set the tool length offset. We set 0, 0 with the first tool, and then from there on we want to go to tool. This is actually tool number 3. That's what it is in. So tool 1 is left cutting. Tool 2 is the right cutting triangular bit. Tool 3 is our cutoff bit. So that's tool 3. And then we want to save offset for tool. Oops. What's the problem? So we have our X is
Not 0?
not 0. This is a 0 for Z, which is 4470. Can we remember that?
4470.
4470. We can write it down. Someone have
We
something?
got it.
Okay, we got it. 4470.
Yep.
Oh yeah, 4632.
What? No.
It's on video, we can just
4470.
It's negative.
Negative. Thank you.
Whoa.
All right. So now even I can remember it. So we're going to jog. Again, now we need to. It's going to take forever. So again, we find the Y offset. Is it stopping right there? Yeah. So this is as far over as we can actually go. It doesn't want you to run into the stop.
That makes sense.
And this tool is on the right rather than the left, so it doesn't look like it's going to hit. So now we basically need to come in again.
Oh.
All right, so now we have a nice dent in our... This is why we use wood when we're learning what we're doing. Because wood...
It's because we're on jog.
Slow the jog down.
Yeah, we
Please, Jay.
slow down.
Wood grows on trees.
All right, that's pretty close. Let's try this. Check out a nice hole in our paper. All right, so that's our 0. Oh shoot. Oh no. That's right. We're setting our X. So 0.58, 0058. Remember that?
Yep.
Okay, so 0058, 0058. And that was positive, right?
Yes.
All right, so now we want to go to, the X was
4470.
No.
0058.
I don't know, that's the X.
The Z was
4470.
0.4470, but it was negative.
Oh.
Was it negative?
No.
Yes.
Yes. All right.
Let's go.
Does that look right? Right at the edge of the part? We'll call it good enough?
Perfect.
So now we want a tool, save tool offset, or tool 3. It's saved.
Alright.
All right, now we probably want to back away. And that's the only two tools we're using. And put this back. All right, this is latched in. This is locked in. We basically now set our tool length offset, and then we want to do setup, save changes. All right, so we set up our tool length offsets. We want to save them so that if we run it again, it's saved. Now, if everything works right, we should be able to make our chest piece.
Safety lenses on.
So you set the 0, 0 for both tools.
So we set the 0, 0 for the first tool, and then we set where the 0 point for the second tool is, the tool length offset. For both tools, yeah. So now, let's see, preview, beautiful. Okay, so now what do we do?
Start.
Start. So the first thing this tells us to do is to change to tool 1.
We did that.
We did that already.
Continue.
Done.
Resume. It is a little wobbly, and that's why we're not measuring at that end.
But it straightens out the faster you go.
It doesn't straighten out faster you go. You can't see it. It's wobbly.
Actually, a song called that. Yeah, it's not always.
So you can see on the screen over here, this is what it thinks it's making. And you can see over there to see what it's actually making, and hopefully it's close, yeah. It doesn't show you the little fuzzy stuff off the edge. To make it exciting.
Drop the camera in there. It's got like a paint.
Yeah. It's the fiber reinforced wood. The wood is by definition. Right, so this is now the finishing cut. If I remember right. Mangy. So it's basically doing the outer part first, and then it's going to do the groove part with the next tool. No, because remember the tool is not sharp enough to cut this rounded corner right there. So that's why I was having issues. So hopefully I established the edge of the tool properly. Otherwise we're going to have a... All right, it's a stick. All right, so what do we do next?
Change the tool.
Change the tool.
Delta tool. Wow, it's a really tiny stick. Yeah, I know, it's way smaller than I was waiting for the top tool. It's got like a teeny.
All right,
Doesn't
now you
it?
hit reserve. And now it's going to, actually it didn't access to change the tool yet. And so it's going to, next thing it's going to do is say, oh, it completed that operation, so it stopped. And now it's asking for the new tool.
What if we change it pauses twice?
It doesn't ask, it didn't ask us the first time.
It pauses between operations.
It pauses between operations and then we ask for a tool change. Okay, where are we? All right, let's watch the magic. See if my correction on it made it right. Okay. So now it's doing some grooving operations. The profile.
Sometimes it's
And really slowly. And oh, we established 0, 0 wrong on this tool.
What do you know?
Doesn't think it's cutting it.
No, it thinks it's a ways off, and it is. How do you know it's wrong?
Because it should be tracing this outside edge. So what we did is we established 0, 0 on the inside, and where it actually should have been established on the outside.
It's definitely cutting it.
That means that it's gonna cut off.
Cut off. The ball is going to be slightly offset, yeah.
I'm in LA next year. I don't know where that is, but how the people at home know too.
So we're going to end up with a stick.
It's like, it's fuzzy.
Is it interesting?
Oh.
And it's done. Oh.
It's cutting off. And again, it's cutting off the tool thickness.
Oh, cool. So the part's gonna drop and fly around?
No, it's just going to drop.
I think it's gonna fly. Oh. Fly around, fly around.
Fly away.
Nice. Oh.
And there we almost have it.